Hi, I'm Karan Arora. I'm the founder and CEO at Tonic Solutions. I'm a chief data scientist and the corporate trainer having more than 7 years of experience, and I consistently recognize for my strong leadership and high service level impacting project success, problem solver, data scientist, data engineer, and with outstanding service oriented background in big data analysis, statistical modeling, database querying, and information security analyst. So further, if you want to know about me, you can just search my name on Google. So you will get all my details. On the first page, you will get my LinkedIn profile, my YouTube channel, and my Twitter profile, Facebook profile. So everything you will get on the first page, second page, third page, fourth page. So today's our main topic is that is big data. So we will start with what is big data and how it is being used and why it is so popular and why the each and every companies is using big data. Um, so firstly, we will start with yeah. So most of the we people already work on Excel, on MySQL. So we mostly worked on Excel with the file size in KBs or in MBs. We haven't worked, even we haven't seen any file size which is in GBs, which is in terabytes, gigabytes, petabytes, zettabytes, right? So we mostly work on a file which is in KBs, which is in MBs, or hardly which is in GBs. So the file which are in GBs mostly they are the movies or they are the softwares, right? So we haven't opened any Excel file which is in gigabytes, which is in terabytes. So we haven't tried even a pivot table more than 500 MB file. Same in case of SAS and R. We haven't even tried a frequency table on 2 GB file. Same if we talk about the Microsoft Access. So we haven't tried running a query on 10 GB file. Same for SQL. We haven't tried running a query on 50 GB file. So how much time it will take? So this is the main challenge, how we can handle a large amount of data. So big data is the data which is not in kilobytes, which is not in megabytes, which is not in gigabytes. So data which is in petabytes, zettabytes, this is known as big data, right? So data which is very large in size is called big data. So normally we work on the data which is of size in MBs. Simply we talk about the Word and Excel file, or on the maximum size which is in GBs, that is movies and softwares. And but the data in petabytes is called big data, right? So it is stated that the almost 90% of the today's world data has been generated in the past 3 years. So what data means really? A big data is a collection of large data set that cannot be processed using traditional computing techniques. So we cannot process the data with Excel, right? We cannot process the data in SQL, right? The data which is very large in size, how the companies handle a very big amount of data. If you talk about the Facebook generate 100 terabytes of data per day, 100 terabytes of data per day. So how they handle this much amount of data? So if we talk about the amount of data produced by us from the beginning of time till 2003, if we talk about the beginning of time to till 2003, the size of data was 5 billion gigabytes, right? So if you pile up the data in the form of disk, it may fill an entire football field, right? So the same amount was created in every 2 days in 2011. From starting to till 2003, the size of data was 5 billion gigabytes. Same data is generated in 2 days in 2011, and in 2013 same data is generated in every 10 minutes. So in 2013 same data is generated in every 10 minutes, and now you can see in every second this much amount of data is being generated. So our main challenge is how to store this amount of data, how we can process the data, how we can analyze the data, how we can transfer the data, and how we can visualize this kind of data. So here we have a solution called big data and Hadoop. So we will talk about the later on. So next, can you think of running a query of 20,980 GB file? So we haven't tried, right? So what if we get a new data set like this every day? So what if we need to execute a complex queries on this data set every day, right? So this is our main challenge, how we can store, how we can analyze the data. And if you talk about the Google, and Google deals this kind of data, that means 20 petabytes of data every day, right? So we have in our system we have a maximum hard disk space of 1 terabyte, or we can say 2 terabytes, 10 terabytes. So maximum, this is the space which we are getting in our laptops, but Google deals 20 petabytes of data every day. So where they store the data, how they process the data, how they visualize the data. If you talk about the Facebook, if you upload a picture on a Facebook, and instantly you can say, everybody can see that in your picture, this is the total number of likes, this is the person who commented, right? So there are a million billion of people are on the Facebook, and within a fraction of seconds everybody come to know that. Same way, if I upload a video on YouTube, everybody come to know that the video is public, and everybody can access my video from any point of right. So this is the how they handle the big data, and how in very fast way they analyze the data or they show the data, right? So next, if we talk about things that happen every minute around the world. So if we talk about the email user sends more than 204 million messages every minute. Every minute, 204 million messages. If we talk about the mobile, web receives 217 new users. So Google receives 2 million search queries in a minute. And YouTube users upload 48 hours of new video every minute. And same if we talk about the Facebook users share 6 lakh 84,000 bits of content, and Twitter users send more than 1 lakh tweets in a minute. And if you talk about the consumer, spend $272,000 on a web shopping in every minute, and Apple receives around 47,000 applications download. Same way, brand receives more than 34,000 Facebook likes. Tumblr blogs owners publish 27,000 new posts. Instagram user shares 3,600 new photos. Right. So this is happening in every minute. So further, what comes under big data? So how the data is being generated, why that the data is in very large, and how the data is being expanded every day. So there are some factors that you can say that that comes under the big data. So first is your black box data, power grid data, transport data, search engine data, social networking sites, e-commerce sites, weather station, telecom company, and share market. So first, if you talk about the black box data, in the black box data, it is a content of helicopter, planes, jets. So it captures the voice of the flight crew, recording of the microphones and earphones, and the performance informations of the aircraft. So every day, every seconds, it generates the data, and it sends the data right to the main station. So same if you talk about the power grid data, that hold the information consumed by a particular node with respect to a base station. So if you talk about the transport data, that includes the model, capacity, distance, and the availability of the vehicle. So this data is generated day by day, and it is uh, growing day by day. So if you talk about the search engine data, search engine retrieves a lot of data from different databases. Same social networking sites from Facebook, Google, LinkedIn, and all these sites generate a huge amount of data on a day-to-day basis, and as they have the billions of users worldwide. So if you talk about the e-commerce sites like Amazon, Flipkart, Alibaba, and they generate a huge amount of logs from which users buying trends can be traced, right? So which particular person is interested in which particular product, right? So they know the customer behavior. Same if you talk about the weather station, all the weather stations and the satellites gives very huge data which are stored and manipulated to forecast the weather, right? This is the temperature for this particular city, for this particular state. So we can know the weather at any particular time, that this in this particular state or in this particular city, the weather is this, and humidity is the wind speed is this. Same if you talk about the telecom company, like Airtel, Vodafone, Geo, right? So they study the user trends and accordingly publish their plans, and for this they store the data of its millions users. And same if you talk about the share market, stock exchange across the world generate a huge amount of data through its daily transactions. So every second, the stock price is up or down. So this is also generating a huge amount of data. Next, we can characterize our data into three categories. This is a three V's of big data. First is the velocity, variety, and volume. If we talk about the velocity, that is the data is increasing at a very fast rate. So it is eliminating that the volume of data will be double in every 2 years, right? So already we discussed that more than 1 lakh tweets in per second. And if you talk about the variety, nowadays data are not stored in rows and columns. Earlier we stored the data in rows and column, which is the data is structured, as well as nowadays data is structured, semi-structured, or unstructured. So most of the data which we are dealing, that is unstructured data, right? So we if we talk about log files, CCTV footage, right? These are the totally unstructured data. So data which can be saved in tables are structured data, and the data which are not stored in the tables, or you can say in a tabular form in a row and column. So they are that is your might be semi-structured or unstructured data. If we talk about structured data, the data like transactional data of the bank, which is stored in rows and columns. So that is a structured data. Next is the volume, the amount of data which we deal with its very large size of petabytes, right? So we have three V's: velocity, variety, and volume. At what speed the data is increasing, what kind of data we are getting, and what is the size of the data, right? Velocity, variety, and volume. So in structured data, that is mostly your relational database, or you can say your MySQL database. If you talk about the semi-structured data, that is your XML and JSON data. So if you talk about the unstructured data, where you can see your Word files, PDF files, text files, media logs, audio and video. So we are having major challenges that associated with the big data: how to capture the data, curation of the data, how to store the data, how to search from this amount of data, and how we can share the data, how we can transfer the data, how we can analyze the data, and how we can present the data. Right? To present the data means we want to present in any of the bar chart, line charts, scatter plots, pie charts, right? So this comes under data visualization. So we have three field in data science also, that is data cleaning, data analysis, and data visualization. Same way, we have also having the same challenges over there, but in data science or in machine learning, the data size is very small, and but in big data, the size of data is very, very, very large. So most of the companies use big data, and there they apply a machine learning model, right? So we can also use a same data science and machine learning fields in our big data. So there are many different libraries are available, so we can use that also. So next, if we talk about what is Hadoop and why it is useful. So Hadoop is basically an open source framework from Apache, and which is used to store and process and analyze the data, which is very huge in volume. Right. So basically, Hadoop is not a database. Right. Hadoop is not a database. Hadoop is a simply open source framework from the Apache, and which is used to store, process, and analyze the data, which are very huge in volume. So Hadoop is basically written in Java, and it is not online analytical processing. It is a use for batch and offline processing. So it is being used by Facebook, Yahoo, Google, Twitter, LinkedIn, and many of the companies, right? So moreover, it can be scaled up by just by adding a nodes in the cluster. So for we have four things: storage, processing, analyzing, and cost. So if we talk about the storage, the huge amount of data, Hadoop use HDFS. So we have two frameworks, HDFS and MapReduce are the two components of the Hadoop. HDFS, that is Hadoop Distributed File System. And if you talk about the MapReduce, this is a processing framework, right? Which helps you to parallelly process the data. So first, if you talk about the HDFS, that is Hadoop Distributed File System, which use commodity hardware to form clusters. So we store the data into the form of clusters, and the data is stored in the distributed fashion. So it works on write once and read many time principle. So just we have to write once into our Hadoop distributed file system, and we can read multiple of time, a couple of times, right? So if we talk about the second framework, that is MapReduce. So MapReduce is applied to the data distributed over network to find the required output. So this is the processing framework: storage, HDFS, and processing, MapReduce. So just you need to remember two things. If you want to store the data, then we will use HDFS. If we want to process the data, then we use the MapReduce. If we want to analyze the data, then there are many different databases, or you can say many different frameworks are available, which are Pig, Hive, Scoop, Flume, HBase, Spark, Scala, Impala. So these all are the terms which are used to analyze the data. And if you talk about the cost, so Hadoop is open source and which is freely available. Anyone can use it, and there is no any supercomputer required to store or to process or to analyze the data. So you can configure Hadoop in your system as well, right? So we do not require any supercomputers. So next, if we talk about the ecosystem, so basically that is your uh, MapReduce, which is used for parallel computing, right? So we cannot put multiple CPUs in a machine. So to write a code that will calculate a 200 parallel counts, and so we required a supercomputer for that. But if we talk about map reduce, so this will do the parallel computing. So it will utilize your all the resources, it will utilize your all the cores, all the processors. So if you have a dual core, if you have two processor and have a multiple core, so it will utilize all the cores, all the threads, right? So it will process the data in a parallel way. So how Hadoop is useful? So it is a very scalable, right? So we can simply store and process data which is of petabytes, and it is very economical. So it distribute the data and process across the cluster of commutative, commonly available computer. You can say commodity hardware, and efficient. If you talk about the efficiency, by distributing the data, it can process it in a parallel on the nodes where data is located, and it is a reliable. Reliable means it automatically maintains a multiple copy of data and automatically redeploys computing tasks based on the failure. So if your one system is down, if my data is stored in my system, right? So then if this system even stop working, then still I can access the data. Means the same amount of data, same copy of data, which is stored in the multiple computers. So it will not store the data. So it will store a multiple copies of data in one system, in another system, in you can say, if we can say I am having a 10 computers. If I am having a 10 computers, I can join all the computers. So it is simply a master slave architecture. So one will be the master who manages all the system, and another is a slave. So where we can store the data. So if you have a computer lab, right? In your computer lab, we have having 50 computers. So we can store the data in 50 computers, and we can join all the systems. If we having, you can say, a 1 terabyte space in each of the system, so we are having now a 50 terabytes. So in, you can say, after a 6 months or after 10 months, I need to store more data. So simply we can add the computers and we can join with the help of Hadoop distributed file system. So simply we can scale up the data, right? So this is the Hadoop ecosystem. Uh, the first, if we talk about, that is Hadoop distributed file system. So in the first, that is your HDFS. After the HDFS, we are having our map reduce framework. So which is HDFS, which store the data, and to process the data, we need a map reduce framework, or you can say YARN. YARN is also, earlier we start with the Hadoop 1, then we shift to Hadoop 2, and now we are working on Hadoop 3. So in Hadoop 1, we are having a size of clusters, you can say a maximum of 4200 clusters. So first time Yahoo create a cluster of size 4200, they simply join 4200 systems, right, to create a cluster. But after they are adding another one node into their HDFS, simply their system crash, Hadoop fails. Then they shift to Hadoop 2, and where you can use more than 10,000 nodes can be added. Right. So nodes mean your system, right? In your system, we store the data in clusters. So I'll talk about master slave architecture. Slave where data is stored, and master to process the data. Slave means your system, or your system, you can call your system as node, and in your node data is stored in clusters, right? So these are the terms that you must be clear about it. After that, we will do the practical of this. And so the data is stored in HDFS, and to process the data we use YARN, that is yet another resource negotiator, right? In the Hadoop one, we use the term MapReduce. In Hadoop 2, this is MapReduce version 2. So they change their name to yet another resource negotiator, right? So there is a zookeeper, which maintains, which keep on track the system, which system is live, which system is rest, which system is dead. So it will maintain all the records. So it will maintain all the you can say logs. So we are having a Pig, Hive, Mahout, Uzi. So Pig is a scripting language, like your PHP scripting language, your shell scripting, Ruby, Perl, Python, right? So these all are the scripting language. Pig is also a scripting language, which is used to analyze the data. So we can analyze, you can say, we can extract the meaningful information from the data, which is in petabytes, which is in zettabytes, right? Same Hive is similar to your SQL. If you are familiar with SQL, right, then Hive is very, very, very easy for you. The main challenge is to set up Hadoop into a system. So that is a task of Hadoop administrator. So if you are a Hadoop developer, then you need to know about how to use Pig, how to use Hive. So if you want to use a machine learning, then there is a Mahout library available, which is used for the machine learning, and Uzi, which is a workflow manager. And the main database, if you talk about the HBase is also used to store the data, which is your NoSQL database. HBase is mostly used by most of the companies. Facebook use HBase to store the data, and if you talk about Make My Trip is also using the HBase to store the data. In normal SQL, what we are having, if we change the password, right, we simply use the update query to update the password. If the email ID is this, and the phone number is OTP is a match with this particular, then we can simply change our password. We change our new password, confirm password, then we use the update query to update the password, right? So Facebook, if we talk about the, sorry, MySQL, we don't know what is the previous password. If we see in a banking system, or you can say in a Google, or you can say in a Facebook, if you change your password, and again if you use the same password, then it will show you message that recently you use this password, or even you can say you use your old password. Even Facebook knows that this password has been changed on this particular date. So they are not using any of the SQL database. They are not using any Oracle database. So we don't have any functionality over there where we come to know that this password has been changed on this particular date, right? So if we talk about the HBase, it stores your previous password as well. So even if you change the password, even they know that this is the password where which we have used in the last three previous passwords. So you cannot use the same password which you have used earlier, right? So this is all being used in HBase. So if you talk about the data exchange, so normally if you talk about the websites are built on you can say the database, they use MySQL, right? So how we can transfer their MySQL data, the websites which are already built, they already having data, but how they can analyze, how they can process the very large amount of data which is already stored in MySQL. So there is a another framework called Scoop. The Scoop is basically used to transfer MySQL database into Hadoop, HDFS. And even if you want to transfer the Hadoop, the data which is stored in Hadoop into MySQL, then we can also use a Scoop. Scoop is basically used for import and export of the database. So if you talk about the Flume, which is being used for the streaming data, the data which is live data, you can say, like if you talk about the YouTube, every second views are increasing, likes are increasing. So this is your streaming data. Or even if you talk about the logs, every second logs are being generated. So if you want to process this kind of data, then Flume is being used. So I'll show you the demonstration on Hive because you are mostly familiar with the SQL, so you can relate as well how the Hive is being used. Hive is being used by Facebook, and it is also being developed by Facebook. After that, they give to the Apache and they launch it as open source. And if you talk about the Pig, Pig is developed by Yahoo, and after that also Pig is being used by the Apache and comes under GPL license, and they launch as it as open source. So Hive, Facebook, and Pig, Yahoo, right? So next, further, if we talk about the data, we are having structured, semi-structured, and unstructured. Structured data, which is being used by Scoop. Scoop can import or export the structured data. So if the data is semi-structured or unstructured, then either we can use APIs. With the help of API, we convert the unstructured data to the semi-structured, and Flume is basically used for semi-structured or unstructured data. Then Scoop, Flume, and any of the other API shift the data to the store the data into HDFS, and from HDFS we use the data analytics, and where we analyze the data with the help of, you can say, Hive and Pig, Mahout, Spark. So many of the libraries are there. And after that, we present the data, that is a data visualization. So we can present the data in web browser. So this is all about the Hadoop ecosystem. So this is just, you can say, a theory of the big data. And if you talk about the applications, so first application, if you talk about in retail or in consumer, so we can use it for market basket analysis, right? If I want to buy a bread, then what are the chances that I'll buy milk, I'll buy eggs, I'll buy jam. So we can use it for the market basket analysis, and also for the customer behavior, right? So customer segmentation for we can also use, and for the financial we can use it for the risk analysis and the management, fraud detection, credit card risk, right? So this is used for in the domain finance and fraud services. Same for the web and digital media. So ad targeting, right? So in everyone's Facebook, you will see a different ad. So I see a different ad, another person will see a different ads. So depending on their interest, same way Netflix like recommend you the movies depending on your interest. Same YouTube suggest you the videos depending on your interest, and same Amazon recommend you to the product depending on your interest. So whatever you're watching, whatever you're seeing, same way they will show you the ads. This is comes under ad targeting, analysis, broadcasting, and optimization, right? So that comes under you can say web and digital media. If we talk about the health and life sciences, so where we can analyze the disease pattern, so whether this person is having a disease or not, so we can use this kind of analysis over there. And for the telecommunication, same, you can say CDR, that is called detailed records. So how uh, like if you talk about the Geo and Airtel, they are having millions of users with them, and simply they just put the number and press enter, so they get all the records, right? So for this particular user is connected with us from this particular time, and every day he consumed this amount of data, and this is the call records on this particular number he used to talk about in this much amount of seconds. So this is what telecommunication companies used for the analysis part. Same for the e-commerce, I already explained you recommendation engines for the predictive analysis. And so this is all the applications, right? Same applications are being used in your data science machine learning part, but same things we can use in big data as well. But their data is which is small in size, maximum in gigabytes, and here the data which is in petabytes, zettabytes. So that comes into a picture. So I talk about HBase. So if I show you uh, job openings of Make My Trip, here you will see there are two profiles. So if we move toward uh, data science field, then you need to know about machine learning, deep learning. So these are the terms which you need to know. You need to know how artificial neural networks works. So then you get a profile called data scientist. So if you shift it to this domain, into this big data domain, and you know about how Hadoop is working, so there are two profiles: data scientist and data engineer. So if you are into big data domain, HDFS, Hadoop, then you get a profile called data engineer. So there are two different terms: data engineer and data scientist. Data scientist, where people work on machine learning, or you can say deep learning. And if you're working on, you can say MongoDB database, HDFS, that is Hadoop distributed file system, HBase, Scala, Java, NoSQL, Kafka, and Spark. So these are the terms which are required. These are the technologies which you need to know if you want to become a data engineer. So if you want to become a data scientist, go to the Python, data science, machine learning, AI. So this is a domain to become a data scientist. And if you want to become a data engineer, then you must know about HDFS, HBase, MongoDB. So many of the companies required both of the engineers, data scientist as well and data engineer as well. So these are the most latest, or you can say most emerging technologies which are demanding nowadays. So now we can start with our Hadoop. So simply, if you want to use Hadoop, you have to download the Hadoop. So you can simply search on Google, download Hadoop. Now we can start our practical session. So this is a website, hadoop.apache.org. So Hadoop 2.10 is available, and Hadoop 3.1.4, 3.3.0, 3.2.1, and 2.9.2. So you can download any of the Hadoop version, so which is quite similar to download. So you can go to the mirror site. After that, you can go to the HTTP site. So from there, you can download any of the version. Like if I want to download Hadoop 2.9.2, so I'll simply download this tar.zz file. So to use Hadoop or use Hadoop or use big data, you need a Linux operating system. In your Windows operating system, you cannot use a big data, you cannot install your Hadoop. So you required a Linux operating system. So I use Ubuntu operating system to use Hadoop and to configure the Hadoop. So I simply download this file and I simply extract the file in my downloads, and there is a file Hadoop 2.8.4. So I'm using Hadoop 2.8.4 because 2.9.2 is not compatible with the HBase. So if you want to use HBase, you have to use Hadoop 2.8.4. So that's why I use 2.8.4. I'm not using 2.9.2, or even I'm not using Hadoop 3 point something version, right? So which is not compatible with HBase. Yes, if you want to use Hive and Big, you can use Hadoop any version. So they are compatible with almost all the version of the Hadoop. But if you want to use HBase, you have to shift to the previous version, that is Hadoop 2.8.4. So these are the some libraries bin etc include library, some log files, system libraries, share folders. So in bin, so there is your Hadoop, HDFS, and so these are all the things which you need to store in any of your location. I simply download and extract in my downloads folder. After that, you have to set the path. So firstly, you need to install the Java, right? So to install the Java, you can, if you are familiar with the Linux operating system, that is well and good. If you're not familiar with the Linux operating system, so you can simply install Java with the help of sudo apt-get install and your Java platform. And also there is Ubuntu Software Center. So this is the Ubuntu Software Center. So here you can simply search Java and you can install the Java as well. So even you search on Google how to install Java in Ubuntu, so it will show you the commands, and simply you have to put all the commands in the terminal. Like Windows, we are having a command prompt, and in this Linux operating system, we are having a terminal. So this can be opened, you can search over there, you can simply search terminal, you will also get, or you can use a shortcut called Control Alt and T. So this is similar to your command prompt. And so this is the first command, that is pwd. This shows your present working directory and what are the directories and list. If you want to see a list of files and directory available there, you can use a command called ls, so which is used to list the files or list the content of file or directory. And after that, there is a command called desktop. I can simply move to desktop with the command cd desktop, right? Cd is change directory. So this is similar to your command prompt cmd, which are used in your Windows operating system. So the commands are almost same, but there are some you can say key difference are there. This is a case sensitive. So if I want to come back, if I again write, if I write cd desktop, if d is small, then it throws some error like there is no such file or directory name called desktop. So this is a case sensitive. If d is capital, I have to write d capital, right? So I come into the desktop, and these all are the files which are available on my desktop. Same way, if I want to create a file, a directory, I can use mkdir, and after that I can create a directory called cdc. And if I write ls, you can see there would be a directory called cdc. And if I want to move to that directory cdc, so I shift it to that particular directory. If I want to check the path, this is home, username is Karan, there is a folder called desktop, and there is another folder called cgc. So if I go to desktop, and there would be folder called cgc. So if simply I can create a file called like hello.txt. So this is a text file. So same way you can see in your terminal as well. If I write ls, you can see a file called hello.txt is available. So I can also create a file called cgc.txt with the help of uh, command called touch. So if I check graphically, you can see there is a file called cgc.txt. So this is how your Linux operating system works. So I'll not go to into the deeper part of this, how the Linux is being working. So I simply start my Hadoop. To start the Hadoop, you need a command called, first I'll write one command jps, that is Java process status. So firstly, I need to start my Hadoop distributed file system. So you need to write start dfs.sh. So I'm simply starting my Hadoop distributed file system. So it will show a two daemons called name node and data node. So it will show two things, name node and data node. So you can see it shows starting name node and starting data node. So these are the two things, name node and data node. data node where data is being stored, and name node is that thing where your metadata is stored, like at which particular location your data is being stored. So that comes under name node. Where data is actually stored, that comes under data node. So if I write JPS, so you can see I'm having a data node, I'm having a name node. This is a secondary name node, which is a backup for uh, name node. If my this system fails, if my master fails, then this will take over. So data node is there, name node is there. Earlier, I simply write JPS. JPS is your Java process status, like your Hadoop is written in Java. So firstly, you need to install the Java, and after that, you can process anything. So next, I want to start my yarn, which is yet another resource negotiator. So which is your processing framework. So first is your where data is being stored and how data is being processed. You need to start your yarn.sh. These all files are stored in your Hadoop. So if I write JPS, you can see node manager is there and resource manager. So node manager means which is used in slave, so where all the nodes are being managed. So it will come to know that which particular system is live, which particular system is dead, so which is being monitored by node manager. To managing the resource, we use the resource manager. So these all are the daemons for the Hadoop: name node, data node, resource manager, and node manager. So all the commands are available there. If I go to my downloads folder, if I open Hadoop 2.8.4, if I go to bin, so you can see HDFS is there, yarn is there. So I am going to the system binary. So I simply run a command called start dfs.sh. So there is a file called start dfs.sh. So I simply run this file, right? So I run in a directory CGC, right? So I haven't shift to the directory downloads, Hadoop, SBin. So I can run these command from anywhere, from any of the location from my terminal, because I have already set the path. Like if you are familiar with Java, you have to set the path in your environment variables. Same way, I already set the path of this system binaries into my system, that so that I can access these command from any of the location. So I simply start dfs.sh, then I start yarn.sh. So these two are the commands which are being used. And now I simply open my browser. How to verify that your Hadoop is working? You have to open localhost colon 50070. This is a port number. So once your name node, data node, resource manager, and node manager are active, then you can open a browser and you can write address localhost colon 50070. This is the port number where your Hadoop is being installed. So to analyze the data, we will use some framework called Hive Pig, right? So firstly, I'm simply going to utilities, browse the file system. So this is a directory where your data is being stored. So there is a file called suicide.csv, sensor.csv, HBase is there. So there's a data set called IPL pig. So this is the username. So this is a platform where from where you can download the data, where you can store the data, right? So first I need to put any of the file. So if I open this folder, or you can say if I want to make a directory, so I will write hdfs dfs minus mkdir. I want to make a directory where then I need to put a location on my Hadoop. So a directory called CGC will be created with the help of Hadoop distributed file system. So it will not create a directory in your local system. So if I write, there is no directory called CGC. But yes, if I open my browser and if I simply click on go, you will see a directory called CGC. So directory is already being created. So if I want to store a data into my this particular directory, so in my previous directory, which is cd space double dot, there is a file called many of the files are there like sensor.csv. This is a suicide.csv. So if I want to put this file, so I'll write hdfs dfs minus put. I want to put a file suicide.csv. This is the source location and destination location to the folder CGC. So it will copy from my local system to Hadoop distributed file system. So I'm simply copying. So it takes nearly a second to copy a file suicide.csv, which is size of 15 MB. But if I open this file, there are rows more than 2,37,520 rows, which are data is being stored in Excel. And so this is the file. Now I'll use Hive. If you are familiar with SQL, now I'll store the data. I create a table. I put some queries, how Hive is being used. So I simply type Hive on my terminal. So firstly, you need to start HDFS. Then you need to start your DF. First, you need to start your HDFS. Then you need to start your yarn. After that, you can use Hive for analytical processing. So Hive is similar to your you can say SQL. If you are familiar with SQL, then this is very easy for you people, right? Like to check the databases, we use a command show databases. So if I run this query, you can see many of the databases are available. So I simply create one database, create database, then database name. So I create a database called CGC. So where this database is being stored. So you can see I'm moving to my previous directory. So there is a directory called user. There is Hive is already being stored in my system, user Hive, and there is a directory called warehouse means there where all the data is being stored. So in this warehouse, I am having a database cgc.db. So this is my database, and in database there is no any table. So firstly, I'll create a one table. So I'll simply open the file. So I'll put this data into Hadoop cluster. So I'm having a file called suicide.csv. So if I open this file, so it takes too much time to open the file. So even though there are very less number of rows, only 2,37,520, so still it takes too much time. And if we open this file in you can say in your dual core processor, I'm using i5 and having more than 16 GB of RAM, then it open in a fast way. Or even though I am using a commercial series laptop, so that's why it's opening very fast. So if you're using normal laptop, it will take too much time to open this file. So this is a file where you can see state is there, year is there, type cause is there, and causes how what is the reason for the particular person that he used to commit the suicide, and whether he's a female or a male, what is the age group, and this is a total number of suicide. So I am having this much amount of data, like due to cancer, person commits suicide, for bankrupt, for any professional or career problem. So this is the data for all the state for Andaman Nicobar, and this is the data from 2001 to 2012. So Arunachal, Assam, Bihar, Chandigarh, Delhi, Goa, Gujarat, Haryana, Jammu, Kerala, MP, Punjab, Sikkim, right? So this is the data from 2001 to 2012. So I can analyze multiple things from this data set. Like if I want to check only a data for state Punjab, I want to check how many suicide cases till now, right? Total suicides in India till now. So after that, I want to check in particular state how many suicides for this particular state. In particular year in 2001, how many suicides 2002, 2003, or in particular state or in particular year, how many male and female commit the suicides. So this is all about a data analysis where we can use the data analysis part. And further, if we want to predict, so this is case we are having suicide case from 2001 to 2012. I want to predict how many suicide case would be there for 2020. So I want to predict the future. So where your machine learning come into a picture, right? So there will use a machine learning to predict how many suicide. That is a part of your regression problem where we predict a real time value, right? So firstly, we will simply put this file into our Hadoop clusters, or we can Hadoop table. So I simply create a table. So to create a table, you're very familiar with, if you're familiar with SQL, you know how to create a table, but there is a one difference in Hadoop to create a table, which I'll show you earlier. So simply to create a table, we write create table, then table name. So I create a table called suicide, and there are some columns which are being used. First, I use a column called state, and where I use a varchar of, this is data type, with the size 50. And second, I use column year. So year, we are having data in integer. Next is a type code, which is also in string. So also you can use either varchar, or either you can use string as your data type. So you can use any, either varchar or either string. So next is the type. So again, I simply write varchar with the size 50. And after that, age group. So again, varchar with the size 50. And last is the total, which is available in integer. So after that, you put the semicolon, and your table will be created in your SQL, right? But we will not put any of the semicolon, but you simply need to press enter. After that, you need to write row format delimited. Row format delimited means this is my CSV file, that is comma separated value. The data is being separated in a comma. That means every row is separated with some delimiter, right? And which is your a slash n, you can say. Every data is separated in the next line. So after that, you need to write every field is terminated by fields terminated by. So my every column is separated by a comma. So if I simply write open this file in any of the text editor, I open gedit. So you can say our data is separated by a comma. So what Excel do, automatically break, it use a delimiter as a comma, and first column is being stored in, this is being stored in first column. After the comma, this is being stored in second column, third column, fourth column, and so on up to. So that means I am using a delimiter here, comma. So it is not necessary your data is always being delimited by the comma. It might be separated by hyphen, or it might be separated by a tab. So in your Excel, the most of the times data is being separated by a tab. So where we will use a delimiter, that is /t. So I simply use that all the fields are terminated by a comma, and every row is formatted. After that, you need to put semicolon and just press enter. So this is a way to create a table in Hive. So the data, or you can say the table is already exist in my system. So firstly, I need to use a database CGC. So now I'm into the database CGC. So if I write show tables, there is no such table available there. So right now I'll use a query create table suicide. After that, row format delimited and fields terminated by comma. So this is a way to create a table. So if I write show tables, so you can see the table is being created. And if you want to describe your table, so this is very similar to SQL. So Facebook have very good engineers, which where they are very familiar with the SQL. So Facebook developed this Hive so that their SQL engineers work on this Hive to process a huge amount of data, right? So if you know the SQL, you can easily shift it to the Hive. So this is very familiar with the SQL. So I simply write describe, and if I write to side, so where you can use the metadata, that we are having a column called state, varchar, year, integer, type code, type, age group, and total. So these all are the column names. So now I put the data from CSV file to my this table. So if I go to this warehouse directory, there is a database called cgc.db, and there is a table called suicide. So as you can see, we have created a table, and in this table there is no any data available. So we need to put some data. So to put the data, So I use a command load data local in path. So load the data from my local directory into table site. So what it will do, it simply put the data from my local system into a Hadoop table called suicide. So the data is available at home. After that, the username is Karan, and which is available at our desktop location, and the file name is that is suicide.csv. So it will simply put the data from CSV file into a table called suicide. So simply I press enter. So it is loading the data, and within 1.21 seconds, the data is being loaded. Now, if we want to see the data, so firstly, we will check graphically. Simply I press go, and you can see the file is stored here. So if you want to download this data even, so you simply click on this, and simply you can click on the download. So your data will be saved. So now, right now, we stored our data into Hadoop. So if I simply run a query, select star from suicide, right? So it will fetch 2,37,519 rows. So I simply press enter, and you can see it fetch all the data. So it take 1.6 seconds to fetch 2,37,519 rows. So same way, if you search on Google, it will also show like this query takes this much amount of time. So if I simply search unique solutions, so you will see 81,200 results and 0.46 seconds. So this is how Google calculate the time and fetch a number of results for you. Right? So 2,37,519 rows take 1.624 seconds to fetch this data. After that, if you want to see only a data from Punjab, this is very same query. Select star from suicide, where state equals to Punjab. So I want a data from Punjab only. So it will show the data for Punjab from 2001 to 2012. And after that, if I want to check how many suicides in 2001, 2002, 2003, so I simply write select. I want year wise, right? I want year. Select year. After that, I want a total suicide value. So I want sum of total. So I want year. After that, I want sum of total. So year wise, I want a total suicides for year 2001, year 2002, year 2003, up to year 2012. I want to see a total suicide. So I need to separate the data year wise. So to separate the data year wise, we are having a function called a group by. So select year comma sum of total from suicide and group by year. So group by year means the data will be separated by year wise, and after that every year we are going to calculate a sum of a total column. So here your MapReduce is being used. So you can see a MapReduce framework is working. So total number of jobs. So it is going to launch a job 1 out of 1. So your first reducer is going to work. So firstly it will map, then it will reduce. So firstly 0% mapping is there. After that, first once the mapping is being done, after that it will reduce. So map is done, and after that it will reduce. So here your MapReduce framework is working, and after that you will get all the results. So this is the minimum amount of time to check the data. So we are having a null value over there. Might be we missed one column. So select star from society. Let me check. So the last the column, we are not getting value. This is null. So I need to check describe society. State here, type code, type, age group, gender. So I missed one column called gender. So that's why the last column is missing. So we are not getting the result. So I need to drop table, table name. Again, I have to enter the data. So I simply create table called suicide. First is state, second is year, then type code, then type. After that, we are having a column called gender. So this is varchar. I can write 20, so they are only male and female. After that, each group and total. Then row format delimited and fields terminated by comma. After that, we need to load the data from our local system to Hadoop. Data is being loaded, and we can simply verify the data to run a query called select star from side. So now you can see there is no any null value there. So we simply miss one column, gender column. That's why the data is being null. So it will not throw any of the error, right? In your SQL, if any of the data is missing, if you simply skip one column, then still you will get an error, right? So here you will not get any kind of error, even though the data is we haven't mentioned the column name, still we are getting the data, right? Now I want to check total suicides year wise. I simply run a query. So here your map reduce framework, again it will start work, and it will let us how many suicide in 2001 from 2012. So basically this is being used where data is in petabytes, zettabytes, right? So same query if you run on your SQL, so it will take you can say more than hour, right? So it will simply process that query in seconds. So we will see the result in yes. So in 2001, we are having suicide 9,76,464 in 2002, 3, 4, 5, 6. So as you can see, the year increases, suicide rate also increases. So this is your regression problem where you can use your machine learning model to predict a suicide case for 2020. So we are having a correlation in year or in suicides. That is a part of machine learning that we will discuss later on. So there are many advantages of Hive rather than in your SQL. So many differences are there. So if I want to separate a data state-wise, so this is the Excel file. I simply told you, right? You need to separate the data state-wise. I want suicide Excel file. I want for Punjab, for Goa, for every state, I want the data should be separate state-wise. So simply what you will do, simply open your Excel if it is being opened, right? Most of the time when you are dealing with the big data, so the file will not be open. So it cannot there is a limitation of Excel. It cannot process the data which is where the size is more than 10 lakh lines. So after that the 10 lakh lines, the Excel cannot open the data or cannot process the data. So it will utilize your all the RAM, and simply your system will be hanged, right? So you cannot open the file which is available in very big size. So that's why I'm using a very small size to understand just the concept, how the big data is actually being used and how they analyze the data. So after that, I need to apply a filter. Then for this particular column, I need to apply a filter. After that, I select one column, and then I go to file, save as, put the file name. So I'll do the same task for every state. So it will take a lot of time. So to store the data separate state wise, I'll use Hive. There is a concept called partitioning and bucketing, so which is called data sampling. So firstly, I use a concept of partitioning. So simply, I want to separate the data state wise, what I'll do, I create a table, another table. So right now I am having only one table, that is suicide. So I want to partitioning the table state wise, right? So data is being stored state wise separately on my Hadoop cluster. So I want this. So simply I write create table. So I create a table called suicide part. So this is a suicide partitioning table, and I'm using first first column is your state. So I want to separate the data state wise. So you need to skip that particular column, so which you want to split, right? So um, I'm not using state column. So I simply start with year integer. After that, I want a type code, which is a varchar. Next, the column is type. Again, varchar. Next column is gender. Next is the age group. And the last is the total. So this, we are going to create a table where I skip a state column because I need to separate a data state wise. So simply I skip that particular column. After that, you need to write partition by state, which is a string, or you can say a varchar. Row format delimited, and all the fields terminated by comma. In this way, you can create a table called suicide partitioning. So where the data will be partitioned by a state, and rest everything is same. Only you need to add one line partition by straight. So I simply press enter. So you can see a table is being created. So right now I'm having a two table, suicide and suicide part. So if I write select star from suicide part, so this table is empty. So there is no any such kind of data is available. So right now I want to insert a data into suicide part table where partition is state wise, and I want to select year, type code, type, gender, age group, total. From which table? From suicide. So I'll copy the data from this suicide table into suicide partitioning table. So after that you will see a result. So insert into table. Table is your suicide part, and the partition is state. So you need to mention from which you are going to use. And after that, what columns you want? I want select year. After that, I want type code. Then I need a type, then age group, so there is one another column, gender, then age group, then total, and at the last you need to mention state. So from where you're going to partitioning, you need to mention at the last. From which table? Suicide. Now press enter. So by default, you cannot do the partitioning. This is a non-strict mode. So you need to set hive dot execute dynamic partitioning mode non-strict. So by default, the mode is strict. So you need to copy this line and paste so that we can do the partitioning as well. So every query end with semicolon, and after that again I'm going to run insert into table. Suicide part partition state wise, and I want to select year, type code, type, gender, age group, and total. And after that, from where the data is being partitioned, you need to mention that column. From which table? Suicide. So right now there are 3 jobs parallelly running. So in the first job, it will separate the data state wise. Let's say first 4 columns, first 4 states. After that, next 10 states would be partitioning by a second job, and next 10 states would be partitioning by a third job. So hardly it will take a few seconds, then you will see a results. Every data is being partitioned by a state. So the result will be very interesting. So I'll show you in the graphically way, so how your all the data is being stored state wise. So total 38 partitions are there, and you can see all the data is being partitioned. So all the 38 to 38 partitions have been created. So it simply take 8.8 seconds. And if I open Hadoop, the data is being available at user directory, Hive, warehouse. We create a database called cgc.db, and we are having 2 columns. If you open suicide column, we are having suicide.csv file. Now I'm going to open another table, suicide part, where your all the data is being partitioned by state, and you will see all the data is separated by a state. So if I want to open, let's say I'm going to the next page, you can see all the data is being partitioned by. So if I want to see only Punjab data, I simply click on state equal to Punjab, and after that I simply click on this file, download, and this is the file. So I simply write, this is a file called punjab.csv. So this is a data for state Punjab. So I write CSV so that I can open in Excel as well. In Punjab, we are having 43,520 suicides. So I simply click on this column. So as you can see, 46,350 suicides for a Punjab data. So you can also verify the total suicides we are having for state Punjab. Right. So same way we can verify 6,350 for Punjab, right? So we can write select year wise, or we can say state wise, or simply we can write I want state wise suicide. I want select state and sum of total column from suicide and group by state. So state wise, I want a different data. So data will be separated by a state wise, and it will calculate total suicides, and it will sum up. So we can see if we get the result 46,350 for Punjab, that means the partitions is being created very successfully. So just wait for it. So it will take a few seconds. Yes. So we are getting suicides for state wise. You can see for Punjab, we are having 46,350. Same way, if I open a file, so you can see at the below, you will see here that sum is 46,350. So it is clearly shown over there. If you see at the bottom, you will see sum equals to 46,350. That means partitions is being created very successfully. So there are many other functions available at Hive also, which you can use to process your big data. So this is simply a one framework I show you, that is Hive. Same way your pig is working. So where we store the data in scripts, and after that I run a pig script. Same way you can use your HBase and your Spark, Scala, Java. So many of the things you can use to process to store the data, to analyze the data, and there are also different data visualization frameworks are available. So you can also visualize the data in your Hadoop ecosystem. So this is all the way. So how your big data is being working. This is simply a very simple demonstration. So I'm not running a data which is very huge in size, or simply took the data which is the rows available at 2,37,519, so that you will come to know that what kind of concepts you can see. So each and every data is separated by a column state, even though I can also separate each state wise data is being separated, and after that in every state I want year wise data will be separated. So I want the data from state Punjab, and after that it will be separated by 2001, 2002, 2003, even though you can also do the in same time it will take. So same thing if you do it manually, or it will take, you can say, 1 hour, 2 hours. You need to again apply your filters, select the rows, and go to the file, save as, put the file name. So this is a very complicated task, right? But the same if you need more than 1,000 partitions, more than lakhs partitions, right? So I want to partitioning the data every day wise. So I am having a logs from the past 1 year. I am having a log file which is of 2000 GBs. So I want to separate the data from log file every day wise, or every hour, hourly, right? So this is how your partitioning come into a picture, right? So you can partition the data into your Hive system. So this is all about how your big data is being working. So I cannot explain all the things in a one webinar. So it is a very huge and very vast topic. So I just simply clear the concepts. What is actually a big data, how it is being used, and what are the challenges we are getting in big data, how to store the large amount of data. So companies are using commutative hardwares, they are using master slave architecture where your data is being stored, and they simply scale up the nodes by adding nodes into your Hadoop clusters, right? So this is all about the big data. So if you have any queries, you can ask me in the chat box. Any queries if you have, you can ask me in the chat box as well. The first question is how the companies earn if they're open sourcing. Okay, so the first thing, if you talk about the Linux operating system, like the Linux is also an open source, right? You can get a free of cost. But if you talk about the certification, so if I want to be a Red Hat certified engineer, so their certifications are paid. So these are the open source are available for only a client base. So I'm using this operating system. This is a client based operating system. If you want to use a server based operating system, then you need to buy a license, even though you have to pay a license for if you're using Red Hat, or if you're using any of the server based operating system. And if we even if we talk about many of the libraries are being open sourced by Google. For example, scikit-learn, TensorFlow. So these are the library built by Google, and after that they launched the open source because they want to know that how other people use their libraries and what other things they can do with. So they simply do the hackathons. So from there we enhance their knowledge as well. So from this particular libraries they can use. So from R they learn. So I simply if I talk about Google AdSense program, right? So many of the people, what they do, they see the ads are running on their websites, and so ads are running on their YouTube. They simply click on the YouTube, right? So somehow the YouTube come to know that, and sometimes YouTube ignores, and you become very happy that I uh, click by myself to earn the money from YouTube, right? So this is how YouTube learns from you. So they learn the patterns from you, that this is a thing a user can do, these type of things to earn or to do invalid clicks. So if I open my AdSense account, even though if the clicks are genuine, still it will show me an invalid clicks. So every time they simply uh, deduct some dollars from my AdSense account. So if I open simply my one AdSense account, you can see um, how Google do the analytic process. So if you want to shift into a non-technical background, so you can start your own venture, you can do blogging, you can become a YouTuber. So from there you can earn a lot of money, right? So this is the payment which I received last month. So I earn more than thousand of dollars every month from a YouTube. So even if I don't do any work, I in this lockdown period I simply sit at home. I don't do any of the thing. I simply launches my own free courses, and from how I earn, I'll show you. So I launch a beta website to just demonstrate. This is the website where I simply do a cloning for Udemy, and you will see many of the advertisement are at the top. So you can see one advertisement is here for Geeks for Geek, and these all are the courses which I launch free of cost. The courses for a case study on COVID-19, getting started with Python, a data cleaning, all the courses are available in Hindi language, and the case study on suicide with the help of machine learning. And this is the movie data set, how XGBoost algorithm work for regression classification. Right? So these all are the free of cost courses available at my platform. But how much I earn, right? So these are the advertisement. So if I simply click on any of the course, advertisement will be there. So this is advertisement for the data camp, right? And after that, you will see a course, right? So I earn from these advertisement, right? So from these advertisement, you can see I earn more than $1,000, right? So in this way, you can start your own career if you want to become a YouTuber, if you want to become a. So this is one AdSense account. I'm running more than 5 AdSense account. So more than 1,811 students already enrolled. So you can also access these free courses, which are at itonicSolutions.com/courses. So this is the link. Uh, can we use Hadoop as a database for Android? Yes, you can also use Hadoop for your Android operating system. Any of the other questions, if you want to ask, you can ask. So companies are earning from different platforms. This is not necessary if they are launching open source. That means they are not earning. They are earning many. So some of do like if I launch these courses open source, I earn from Google, right? I earn from. I simply offer you a free courses and I earn from Google advertisement. There is no any coding required for Hadoop. This is very simple. Simply you need to know about the databases. So this is all about the database. Same HBase is also database, which is your NoSQL database, and Hive, Pig, same. If you are familiar with the databases concepts, then it is very easy for you. Any other doubts?
So I hope all the questions of students have been covered. You already had given them a very vast knowledge about practical demonstration about, you know, about the Hadoop and big data. So I think all the questions are covered in the practical demonstration only. So now I would like to, students, if you have any other questions, you people can ask in the
Still,
chat
you have
box.
any doubts, you can connect with me on LinkedIn. So from there, you can ask me.
On behalf of Faculty of Management and the Faculty of Computer Applications, students of Computer Application and the head of the department, Chandigarh Group of Colleges, Jhanjeri, I would like to take this opportunity to propose a vote of thanks to our eminent speaker, Engineer Karan Arora, who is founder and CEO of Electronic Solutions Mohali, who spared the time from his busy schedule and provided us an informative workshop on big data and Hadoop. Thank you so much, sir.
Thank you, ma'am. Thank
You
you.
have very well explained what is big data,
Thank you.
what is Hadoop, and really we are our students have given me a feedback, very positive feedback that they have been provided with a practical demonstration, which is very much required these days. So students
Thank
are
you, ma'am.
really
Thank you so much.
happy as they have received this information that Hadoop, which is an open source framework that supports the processing of large data sets that we have these days in a distributed computing environment, they are really happy to hear everything and to see each and everything about the Hadoop and the big data. Thank you so much, sir, again. It's
Thank you,
been
ma'am. Thank
pleasure
you
for
so much.
us to have you through online platform, through a virtual platform for the students, where students will be able to get these kind of information.
Thank you, ma'am. Thank you so much.